Hello. So this is my presentation of my Applied IoT project. My name is Mikael Johannesson, and I've chosen a project called Remote Temperature Log with Local Alarms. And this, of course, is a part of a Course 1 DT 305 Introduction to Applied Internet of Things at LMU. So, something about my problem. I define my problem like some IoT devices are probably needed. What I wanted to do was to store data for long-term use. I wanted to have some local alarms, and I wanted to retrieve some data from a sensor. By that, I came up with some blocks of how to do this. I wanted to use a PyCom LoP4 device. I wanted to use Pybytes as an IoT hub to receive data from a LoP4. I wanted to use a second Azure IoT hub, trying MQTT forwarding, and also it was practical in order to work with an SQL database in Azure. By that, I had to select some tools, and I chose to go with the suggested PyCom LoP4 device. Visual Studio Code as my main idea, Python as my coding language, obviously, and some discrete components for local alarms, LoP4, PyCom's LoP4 device. I went for two different MQTT brokers or IoT hubs or whatever you call them, one from PyCom and one from Microsoft for reasons I'll discuss later. By that, the three first blocks in my solution, they were sensor, a PyCom LoP4, and alarm signals. And for those, I had to do some electrical design, writing a circuit diagram, selecting sensors and components, and some calculations on how to put them together. I came up with this solution, and I built a solution looking like this. So this is my mock-up for this solution. Next step. We now have the physical part, and we have programmed it in a way that it does send data. Next step is to implement an IoT hub, and we choose to go with Pybytes from PyCom for that. It is easy to implement with PyCom's devices, so by that I chose it. Using that, I did some settings. I defined some signals. I actually used one of the signals for error messages from my PyCom device, so I do get all the error messages for failing connections with sensors, etc., sent over MQTT in case there are any. The sensor I had to measure humidity and as well as temperature. And this is the graph of humidity over time. Interesting to see is that the dots are not coming in a straight line. They are different with different times between each dot. And of course the same applies for temperature data. By that, I think I managed to solve the problem of sending data from a sensor and receiving it at my MQTT broker. Next step is how to store it long term in a database. Pybytes do offer to store data for 30 days or 1 month, whatever. Maybe you can pay to store it longer, but one of the problems with Pybytes is that it's not that easy to get data out of the system and ask qualified questions. So I wanted to use another system for that. Microsoft Azure do have lots of interesting resources, and two that were interesting were the IoT Hub and the SQL database. So I went through those. As you can see, obviously you have to find a way to communicate between my IoT Hub and my SQL database. It turned out they had a resource for that as well, and that resource was the Stream Analytic Job resource. Now I'm going to show a few screenshots from Microsoft Azure, as you might want to know what it looks like. Most of you probably haven't seen them. So Azure, Microsoft's virtual machine, virtual anything setup. There are lots of services in Azure, and this is the start page where you can choose to implement any server you want. Of course, there are costs for production levels, but mostly you can test them out for free for a month, for a couple of months, or whatever. So the first I installed was my IoT Hub. Doing so, I was looking at the identities of my IoT Hub and found settings that I use, the keys you can call it, to interconnect my Pybytes IoT Hub with this IoT Hub. And as you can see, I do have my Frank Hose device here. That is my Lopi 4 card. My plan was to store data in SQL, so obviously I had to make it reasonable. I had to reformat it. From MQTT, I received data as JSON, and I needed to send it to my SQL server using an SQL insert question. First, though, I had to make sure I had a proper place to store data in the SQL server, and I designed a table, data1, to store data. It's the same fields that I found in my JSON code, and I also wrote an SQL statement to create this table. By that, it was time to install my SQL database, and obviously put this SQL statement that created my data1 table and run it. And well, by that, I had to have a database to store data. And it's time to do the connection tool, the Stream Analytic Job. For me, a Stream Analytic Job had to be had an input, and that input was chosen to be from my IoT Hub, my Lopi 4 device. And for output, I chose the table I recently created in my SQL database. I also had to write a query, as you can see, that to define what from my JSON code should be put into my SQL table. And finishing by checking the start button in the upper left corner, the job was up and running. Waiting a couple of minutes, I was able to ask a select question to my database, and just receiving two fields, payload and date, for signal 2. And signal 2 in my case is temperature, and that definition was defined in my Pybytes IoT Hub. So now I have managed to send data the entire way, and all the blocks are blue and thus solved. Let's go to the evaluation of the course then, or rather the project, and challenges and limitations for me. One limitation, of course, was to find out what I could test for free and what was that was worth paying for testing. I would have loved trying Microsoft Power BI for presentation, although it wasn't worth paying for it, I decided finally. Also selecting ambition level for each opportunity. There are lots of tools out there, and well, you have to select what to do and what to not do. Doing everything will not be feasible. Unfortunately, I did have some big communication problems with the interconnection between my computer and my LuPi 4 card, so adding new code to my LuPi 4 turned out to be a time-consuming job, unfortunately. I hope that was for me and not for all of you. I also learned a challenge that was irritating sometimes was all those security settings were public-private key pairs. There were different set to allow parts to communicate with each other, and well, good things to have, but took some time to understand what was supposed to be used in a specific communication line. Lessons learned. Well, for first, it was nice to see that public LoRa nets are now up and publicly available. It was interesting to be introduced to a variety of different IoT platforms and tools. And well, one interesting thing was that package of MQTT data are not received within the same time. They are received quite unsteady. It can be some 20 seconds between one and then 30 seconds to the next one or so, due to the packet nature of Ethernet and MQTT. Reading sensors, at least this very cheap HET11 I had, do fail from time to time, as I could see in my Azure log. And one lesson learned for me, of course, was that you should use a clean computer, not used for older development works. Like that, thank you for listening.